Hey everyone, did you know that there's something out there in space that can stretch time, bend light, and swallow entire stars? No, it's not your cat when it's hungry, it's a black hole. Today, we're diving into the wacky world of black holes, and trust me, it's going to be a cosmic roller coaster ride. So hold on to your seats and your sanity, because things are about to get astronomically weird. Ever wondered what happens when a star dies and collapses into a black hole? Let's start with the basics. A black hole is an area in space where the gravitational pull is so strong that not even light can escape from it. Black holes form when massive stars run out of fuel, collapse under their own gravity, and create a point known as a singularity. This singularity is incredibly dense, packing a huge amount of mass into a tiny space. There are three main types of black holes: stellar, supermassive, and intermediate. Stellar black holes form from collapsing stars. Supermassive black holes are found at the centers of galaxies, and intermediate black holes fall somewhere in between. Surrounding the singularity is the event horizon, often called the point of no return. This boundary marks the edge beyond which nothing can escape the black hole's gravitational pull. The event horizon is where things get seriously intense around a black hole. Think of it like a waterfall. Once you're too close, there's no getting back up. Anything that crosses the event horizon, including light, is trapped. Black holes dramatically bend the fabric of space around them. This phenomenon is known as spacetime curvature. Imagine space as a stretched rubber sheet. Place a heavy ball in the center, and the sheet dips and curves. A black hole does something similar. It causes space to curve dramatically around it. This is called spacetime curvature. Objects near a black hole experience this intense curvature. They orbit faster and faster as they get closer. It's like a cosmic whirlpool pulling everything into its grip. Another fascinating effect is gravitational lensing. The black hole's gravity bends light from objects behind it, creating distorted and magnified images. This makes black holes like giant cosmic lenses. And if something gets too close, it gets stretched and pulled apart in a process scientists call spaghettification. The intense gravity stretches objects into long, thin shapes. But black holes don't just affect space, they also affect time. Near a black hole, time moves slower compared to areas further away. This phenomenon is called time dilation. If you were near a black hole for a few hours, years could have passed elsewhere in the universe. This effect is due to the intense gravitational field slowing down time. Imagine you're an astronaut near a black hole. For every hour you spend there, years could be passing by for your friends back on Earth. It's like a real-life time machine, but only in one direction. Interestingly, this effect is taken into account by GPS satellites to provide accurate location data. The difference in time experienced by satellites in orbit and clocks on Earth needs to be corrected for precision. There's a common misconception that black holes are cosmic vacuum cleaners, sucking up everything around them. In reality, only objects that get too close are affected by their gravitational pull. Black holes only affect objects that get too close to their event horizon. If our sun were replaced by a black hole of the same mass, Earth would keep orbiting it just like before. We'd just miss the sunlight. Here's a fun fact. Did you know that black holes can sing? Well, sort of. They emit gravitational waves, ripples in space-time that we've actually detected. It's like listening to the universe's greatest hits. Another cool fact, black holes can be tiny or gargantuan. Stellar black holes are formed from collapsing stars and can be up to 20 times the mass of our sun. But supermassive black holes, like the one at the center of our galaxy, can be billions of times more massive. And here's a sci-fi favorite. Some theories suggest that black holes could be gateways to other universes, or even time travel portals. While this sounds like science fiction, it's a fascinating area of theoretical physics. Did you know that the nearest black hole to Earth is about 1,000 light-years away in the constellation Monoceros? So there's no need to worry about being swallowed up anytime soon. So, black holes are fascinating objects that warp space and time in incredible ways. From their formation to their effects on the universe, they remain one of the most intriguing phenomena in astrophysics. Well, folks, we've reached the event horizon of our video. I hope your brain didn't get too stretched by all this talk of black holes warping space and time. Have any questions, comments, or topics you'd like to see? Drop them in the comments below. Until next time, keep your feet on the ground and your eyes on the stars. And remember, in space, no one can hear you laugh. But that doesn't mean you shouldn't try.